Hello, GED students. Let's look at a GED style example that could be easily done with the skill of substitution we've been reviewing. So example says, find the surface area to the nearest square centimeter of a sphere with a radius of 8 centimeters. Now you might say, Kate, how could we do this with substitution? There's not even an algebraic expression, equation, or inequality, anything in order to be able to sub your information into. And I say not yet, but take a look at what we do know. It says find the surface area to the nearest square centimeter of a sphere with a radius of 8 centimeters. Hey guys, that's a lot of measurement language. I even see that really super important phrase, surface area. And I know that surface area, as well as many other geometry formulas, show up on the GED formula sheet. So go ahead and hit up the formula sheet for me, and let's find the formula that relates the surface area to the radius of a sphere. Hitting up the GED formula sheet under the surface area and volume section, you're going to see that there's two formulas for the sphere. One says SA is equal to yada, yada, yada. One says V is equal to yada, yada, yada. Well, we're looking for surface area. So we want the formula that says SA. So first step, I'm just going to copy down that formula exactly the way I see it so that I make less errors in my substitution. So surface area is equal to 4 times pi r squared. And now let's substitute in anything we know. So remember to go one thing at a time. Let's start with SA. It stands for surface area. It's not two different things. It's just one thing. So find the surface area. Look at that. We're told to find the surface area. It's something we don't know. It's a mystery. And so we're going to just go ahead and leave that as letters in this case, SA for surface area. And of course, when we're doing our substitution, we have to be super careful that numbers don't get lost. If there was a 4 in the original formula, there needs to be a 4 in the substitution step. Now, but after that, take a look at this pi. Careful, pi is not a variable. Pi is a known value. It's a number that never, ever changes. Problem is, it's a long, ugly number. 3.14159, yada, 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 yada. It goes on and on forever. We don't want numbers that go on and on forever. Good news, though, is as far as the GED is concerned, you can use the approximation for pi. So a rounded number that's close enough to pi that it'll work out for us, and that's 3.14. And if you forget that, that is written on the GED formula sheet as well. And notice I plug in that 3.14 in parentheses. Why? Because the 4 and the pi were shoved together. They're multiplying. So I'm going to use parentheses to tell you to multiply the 4 and this value for pi, 3.14. And now next thing I need is R. R stands for what? It stands for radius. So go looking through your problem. Do you know the radius? Well, you do. It says we have a radius of 8 centimeters. That's as nice as it can be when you need an R and they tell you what R is. Very sweet. I will plug in that 8 for the R and then make sure your exponent goes on the outside of the parentheses when you plug into exponential expressions. Doesn't matter in this particular example, but it does in other ones. So have your good habits in place. And now, nice thing is, I should really have a wavy equal sign here, you guys. Not that any of you guys care, but if you're going on to college math, you should know this because I used that rounded version of 3.14. But that's just me being anal. Okay, so let's come back to where I was going. So take a look now at this right-hand side of the equation. See how there's no letters left? It's all numbers. You can plug this entire expression exactly the way you see it into your TI-30XS calculator. So that is what I will do here. I will go 4, open up parentheses, 3.14, close parentheses, open them up again to put in an 8, close it, and then I'll use the X squared button to square it. Press enter, and I get that the surface area is approximately 803.84. 803.84. Now we've got two things to do at the end. One is, and this is especially common when you have anything involving circles, so like a spherism, like a three-dimensional circle, a ball. So anytime you have something involving circles, watch out for rounding directions. And then when we're in the land of algebra, we should know what we're finding and what we're doing. So I'm going to get a unit. Although honestly, on the GED, they probably won't make you do the unit yourself, but I want you guys to have this kind of awareness. It's going to make you better at interpreting word problems when we get there. So two things, rounding. Let's see if we have rounding directions. Find the surface area. Found it. See that rounding language? To the nearest square centimeter. Now you might say, Kate, that's not a place value, square centimeter. It's not tenth or hundredth, or it's just what? What place is that? Well, if it just specifies a unit, so in this case, the unit is a square centimeter, in general, I can only think of one exception, but in general, we're talking about to the nearest whole centimeter. So the nearest whole number, or the ones place. Basically, we're breaking things off at the decimal. So I'm going to end my number right here at the decimal. But remember, you can't just throw out numbers without deciding whether or not you're actually further than it looks. Basically, are you halfway to the next number yet? So are we closer to 803 or are we closer to 804? The way to tell is to look at the next number, the one you're about to throw away, and see if we're halfway through our digits. Well, we are, right? If we're 5 or higher, we've hit the halfway point. And so what's going to happen is we're still going to lose that 8, but its last final dying act will be to bump its buddy up. We're going to see that we're actually closer to 804. That surface area. And 804 what? Well, there was a clue in the problem again, but surface area, like any type of area, is measured in square units. So it's not going to be regular centimeters, it's going to be square centimeters. Now, can you spell out square centimeters like this? Yes, you can, but I'm resentful that you're making me do this. Plus, it makes my hand hurt. I'm a lazy mathematician. So I'm going to abbreviate it. No mathematician worth their salt is taking the time to spell. We have better things to do. Y'all, I give mathematicians such a bad name. And so what I'm going to write here is the abbreviation for square centimeters, which just looks like cm for centimeters with a little 2 on it. And that's not math to do. That's just me being too lazy to say square centimeters. All right, final answer, 804 square centimeters. That's how many little curved squares in this case, but how many little squares it would take to cover the surface of a sphere. All right, you guys, super proud of you. Nice, experienced kind of example of just using formulas. A little bit scary of a formula for some students, but wasn't too bad, was it? We can totally do this, especially with our formula sheet and our calculator, which we would have both if we were doing this on the GED. All right, you guys, super proud of you. Happy learning.